All right, hi everyone. Today I'm going to be talking about how sign language is processed in the brain. This is what I was studying for this class. This is what my paper's on. So I'm just going to review some of the current literature and kind of get into my conclusions. This is a really interesting topic to me. I'm a sign language minor. This little banner here is an American Sign Language. It's spelling out learn, which is fun. And then the sign for that is learn. Okay. So to start, I just want to talk about the value of sign language research and just kind of widely the value of sign language. Deaf populations have recognized the value of sign language long before hearing populations have. Obviously, sign language is used for communication, community building, identity, and just kind of progressing the deaf community. Sign language, though, has not always really been respected by hearing communities. It was not viewed as a language by a lot of people for a long time. It's not recognized a lot. However, it's actually a really important research tool for us as well. Understanding how sign language is processed and produced in the brain is really integral to helping us understand language at large. Most of our research is on spoken language models, verbal communication models when it comes to language research. But understanding visual language really helps us to further that understanding. So to start off, I want to talk about how sign language is the acquisition of sign language and also processing. So research has shown that there's a critical period of sign language acquisition. Research additionally has shown that there are critical periods when it comes to picking up spoken languages, and sign language is just the same. We see this because of research that shows right hemisphere activation in native signers. So these are people who have been signing from a young age, people who have acquired sign language before puberty. This includes CODAs, which are children of deaf adults, often hearing children whose first language or second language in the home is sign language, therefore they're also native signers. In both CODAs and just people who have acquired sign language at a young age, we see extensive right hemisphere activation in their brains while processing sign language, and compared to control groups of people who have acquired sign language after puberty, we see that that's more left lateralized, which kind of supports the idea that language processing is generally left lateralized. So this is evidence that there's actually a critical period when it comes to picking up sign language. And I'll talk a little bit more in a minute about different areas of the brain and what they mean. But first, I want to talk about the broader implications of this. So before this kind of research into sign language, we didn't understand that the brain's right hemisphere had a critical period for language acquisition. And so this kind of helps us with that idea that brain areas might be more complex than we originally thought. Brain areas are maybe less specified than we originally thought. And that's just one of the real benefits of understanding sign language research, is understanding how different brain areas can be recruited for different things. So for a little bit of background, I just want to talk about the left hemisphere and the right hemisphere of the brain. Given that we're all psychology or neuroscience or something related students, we likely know some of this, but I think it's important to have a little bit of background for my specific research. So the left hemisphere of the brain is generally associated with language processing and semantic skills. We see research that shows the left side of the brain is more lateralized when it comes to language processing with spoken models of communication. Brain areas that are associated with language in the left hemisphere are Broca's area, Wernicke's area. These areas process and produce speech. And then the left temporal cortex has been associated with auditory processing. We recognize this because lesion studies show that there's a lesion in this area, auditory processing can be disrupted. The right hemisphere is associated with visual processing, spatial reasoning, artistic expression, those sort of things. The right temporal lobe has been heavily associated with visual processing. My little bubble is covering up this last point, but it says implicated with vision disruption when disorder is present. So in right temporal lobe epilepsy, we see visual disruption. It's important to know about the different areas of the left and right hemisphere, the different brain structures within them, because it kind of helps us to get an understanding of why it's so interesting that we see right hemisphere activation in language processing when it comes to signers. And I'm going to talk a little bit more about lateralization patterns in sign language production and retrieval. in the following slides. So the left hemisphere has actually been implicated in the retrieval of words in sign language. Even in native signers, when it comes to retrieving words in sign language, we do not see any right hemisphere activation. This is interesting because this is similar to how spoken language is retrieved and understood. So while there's some differences when it comes to the signing brain, there's also similarities, kind of pushing this idea that sign language is language and that is processed as verbal models are processed as well. There's additional evidence of cross-modality neural plasticity and some activation in Broca's area. This is really, really fascinating. Cross-modality neural plasticity is basically that your brain is able to recruit other areas that are not generally associated with that modality while enacting in some other modality. So for this, primarily when it comes to the production of sign language, motor function, motor areas of the brain are activated. However, auditory areas are actually also recruited. This is interesting because there's no auditory processing that needs to be done to produce sign language or to process sign language, but these areas of the brain are being activated, which is evidence that there's some neural plasticity here, just kind of furthering our understanding of how our brain works and how connections are made. And then Broca's area is also activated when producing signs. Broca's area has been heavily implicated in spoken language, but it actually is also implicated in visual language, which is just kind of an interesting point and shows us again how there's some similarities between verbal and visual processing of language. All right, so let's just wrap things up real quick. In conclusion, understanding sign language is very integral to understanding language. Production, retrieval, processing, all of these things give us a wider understanding of how language is processed in our brains. And then sign language is produced and processed by a few different brain areas. This includes the right hemisphere, which we generally only see in visual spatial processing. And this also includes the left hemisphere, which we understand to be implicated in language processing. So it just kind of widens our understanding of how our brains work, the capacity that our brains have to have cross-modality neuroplasticity, and is just a really important tool for understanding language without the influence of hearing or speech, but just kind of deeper processing and different ways of processing. And these are my references. Thank you.